Okay, for this next one we have a series of negative 2 to the n divided by the square root of n. So this is actually an alternating series in disguise a little bit. So the first thing I did was just write it out in all its alternating series glory. So maybe you want to use the alternating series test. If you look at that a little bit, notice that the b sub n would be 2 to the n over square root of n. 2 to the n goes to infinity faster than square root of n. So when we put those in ratio, they're going to be, the 2 to the n is going to win out. So this is an increasing function, it's not decreasing. The alternating series test isn't going to work. We might suspect also the divergence test. That's something that came up for when we had alternating series that were divergent. Alternating series tests can only be used to show convergence. So by again maybe looking at 2 to the n over square root of n, that 2 to the n is going to go to infinity faster than square root of n. So maybe this thing's divergent. It turns out that the test for divergence, you have to take the limit as, so I'll just write a few things here. Let me backtrack. Alternating series test doesn't work. I guess we can say that. And I'll just write down that our b sub n is actually increasing. Test for divergence, talking about that a little bit, involves taking the limit as n goes to infinity of the whole thing, including the alternating part. So it's actually a little bit easier to look at with the form negative 1 to the n times 2 to the n over square root of n. But that alternating part is really tricky to take the limit of, and it doesn't exist. And then, you know, reconciling this other stuff. So it's possible to take this limit, but I'm just going to kind of avoid that, 5 to 10 minute discussion and just kind of say that this is a hard limit. Yeah, I don't know, maybe this isn't something we want to get too deep in, because it's just a hard limit. You have to be a bit careful. So now let's get to this point where maybe these things aren't obvious, or alternating series does not work just in general, but test for divergence if we're kind of confused about this limit. As mentioned in the example before, there's a lot of these tests that only apply for when our a sub n, or the general term, this package deal with the alternating part, is positive. And that's not what we have here because it's alternating. But some of the tests that do apply are the root and ratio tests. Those can be used, don't have that condition that the a sub n has to be positive or non-alternating or anything like that. So I'm going to try the ratio test. And let's see what happens there. Alright, the ratio test involves taking the limit as n goes to infinity of the absolute value of the ratio of the a sub n plus 1 over a sub n. So writing that out, our a sub n plus 1 is negative 2 to the n plus 1 over square root of n plus 1. And we have all that divided by our a sub n, which is negative 2 to the n over square root of n. And so now the game is that we're supposed to be able to cancel some stuff, and pretty much always the first step here is to write as multiplication by the reciprocal in order to have that happen. So now when you have an alternating series written purely as an alternating series, you can't just get rid of the negative 1 to the n or n plus 1 stuff. But you gotta be careful here because it's negative 2. And turns out if it's not just a 1 or a negative 1 in there, then you gotta be careful. So just kind of showing an alternative here is you can write this as negative 2 to the n times negative 2. That's the equivalent of negative 2 to the n plus 1 times square root of n. And then we have root n plus 1. Negative 2 to the n. They cancel, and then you can see you're left actually with a negative 2, which becomes positive 2. So I'm going to go ahead and drop my absolute values, but sometimes there's a surprise that comes up, so we encounter a negative, so just kind of be aware that if you do drop those prematurely, that when you get a negative, you gotta make it positive. So here's what we have. We have the indeterminate form 1 over, or excuse me, infinity over infinity. I'm just going to do some algebra here. L'Hopital's is kind of messy. Might not even work. Algebra is easy here. So the way I pick this is it's the largest power in the denominator. And so the square root, I'll kind of show an extra step here compared to what I normally do. The square root over square root, I can bring in the n under that root now. So now what I have is 2 over, distributing that division by n, 1 plus 1 over n. So this is the determinate form, because I can take the limit as n goes to infinity, get 0 here, and then overall this limit is 2. So the ratio test worked because we're comparing to 1, and 2 is greater than 1, so therefore we have a divergent series. And again, this was by the ratio test.